Let's have a look at an example where we have a container of soup that has a surface area of 250 centimeters squared. We're asked to find the dimensions of the optimal container which maximizes the volume, has the biggest volume, and we're going to calculate that maximum volume. So here's our can of soup, and we're given that the surface area is 250 centimeters squared. We're asked to find out what the radius is, the height, and the volume for this container. Formula we're going to use is going to be that the surface area is 6 pi r squared, and we'll substitute in the values that we know. We know that the surface area is fixed at 250 centimeters squared. We're going to use pi as being 3.14, and our radius, well, we're not sure what it is. That's what we're going to try and solve for. So if we solve this, we have 250 equals 6 times 3.14 is 18.84 r squared. We'll rearrange this so that we can solve for r squared. And to do that, we need to divide by the coefficient, or the number in front of r squared, which is 18.84. So we'll divide both sides by 18.84, and you end up with r squared equals 13.27. 250 divided by 18.84 should give you 13.27. Now we need the radius, so we need to reverse the squaring process, and to do that, you take the square root of both sides. You should end up with a radius of 3.64 centimeters. Now we know that that radius is related to the height by the fact that the height is twice that value. So when we sub in the radius of 3.64 and we multiply it by 2, you should end up with a height of 7.28 centimeters. Once we have those two dimensions, we can then calculate the volume of this container. So we've got volume equals pi r squared h. We'll substitute in 3.14 for pi, 3.64 as our radius, and 7.28 for the height. When you multiply all of those values together, you should end up with an optimal volume, a maximum volume of 302.88 centimeters cubed. So therefore, the maximum volume, when you have a surface area of 250 centimeters squared, is going to be 302.88 centimeters cubed. And again, it happens when the height is twice the radius.